Welcome to bilingual e-lecture series for diploma students. Today we are going to see the lesson on system of forces in the subject strength of materials for second year mechanical engineering students. Now let us go to the topic. Today we are going to start the class with statics of particles. What is statics? Statics is the branch of engineering mechanics which deals with the study of bodies at rest under the action of forces. It deals with equilibrium of bodies under action of forces. Here the bodies may be either at rest or move with a constant velocity. So statics அப்படினா என்ன? Statics அப்படினா engineering mechanics subjectல ஒரு பாகம். இதில் என்ன படிக்க போகிறோம் அப்படின்னா particles or bodies நிலையாக இருக்கக்கூடிய ஒரு பாடிஸ் மேலே படிக்கக்கூடிய ஒரு சப்ஜெக்ட் பேர் தான் ஸ்டாட்டிக்ஸ். ஸோ இந்த பாடிஸ் வந்து ரெஸ்ட்டில் இருக்கலாம் அல்லது தே கேன் பி மூவ் வித் அ கான்ஸ்டன்ட் வெலாசிட்டி. இதில் முக்கியமான ஒரு கான்செப்ட் என்ன அப்படின்னா ஃபோர்ஸ். ஸோ வாட் இஸ் ஃபோர்ஸ்? விசை என்றால் என்ன? ஃபோர்ஸ் மே பி டிஃபைன்ட் as an agent which produces or tends to produce, destroys or tends to destroy a motion. So force அப்படின்றது என்ன அப்படின்னா it is an agent which produces. அது என்ன பண்ணலாம் அப்படின்னா ஒரு மூமெண்ட்டை உற்பத்தி பண்ணலாம் அல்லது tends to produce. It may act as a agent to produce a movement or it can stop, destroy. Already a particle is in movement. It can destroy the movement of the particle or body, tends to destroy the movement. Force is an external agency which is applied on the body to change the state of the object from rest or state of the body from uniform motion. ரெஸ்ட்டில் இருக்க பாடியை ஒரு மூமெண்ட்டு கொடுக்கக்கூடிய ஒரு விசை, ஒரு எக்ஸ்டர்னல் ஏஜென்சி, அதை என்ன சொல்கிறோம் அப்படின்னா விசைன்னு சொல்கிறோம். அல்லது ஒரு யூனிஃபார்ம் மூமெண்ட்டில் யூனிஃபார்ம் மோஷனில் ட்ராவல் பண்ணிக்கிட்டு இருக்க ஒரு ஆப்ஜெக்ட் மேலே அப்ளை பண்ணக்கூடிய எக்ஸ்டர்னல் ஏஜென்சிக்கு பேர் தான் என்ன சொல்கிறோம் அப்படின்னா விசை அப்படின்னு சொல்கிறோம். ஃபோர்ஸ் இஸ் எ வெக்டார் குவான்டிட்டி. விசை என்பது ஒரு வெக்டார் குவான்டிட்டி. நம்ம எல்லாருக்கும் தெரியும் வெக்டார் குவான்டிட்டி ஹேஸ் போத் மேக்னிடியூட் அண்டு டைரக்ஷன். வாட் ஆர் த யூனிட்ஸ் ஆஃப் ஃபோர்ஸ்? யூனிட்ஸ் ஆஃப் ஃபோர்ஸ் இஸ் நியூட்டன், கிலோ நியூட்டன், மெகா நியூட்டன், ஜிகா நியூட்டன், லைக் தட் ஒன்லி. இன் ஜென்ரல் உங்கள் ப்ராப்ளத்திலலாம் பார்த்தீங்க அப்படின்னா they will specify in terms of kilonewton and usually we are expressing in terms of kilonewton also. So 1 kilonewton is equal to 1 into 10 to the power 3 newton. Mega உங்க எல்லாருக்கும் தெரியும் 1 mega newton is equal to 1 into 10 to the power 6 newton and 1 giga newton is equal to 1 into 10 to the power 9 newton. This is the unit of force. Now we are going to see what are the effects of forces. Already we discussed that force is an external agency applied on a body which is on rest or on uniform motion. Okay, what are the effects of applying this external agency on the body? A force can move a stationary object. You imagine a ball is in a stationary position. Now we are going to trigger the ball. What will happen? The ball will move forward. Okay, so the external agency applied tends the object to move. So the effect of force may be to move a stationary object or a force can stop a moving object. You just imagine a ball is rolling. Okay, if you are going to put your hand in front of the ball on its path, it will stop. So the externally applied agency, that is nothing but the force, can stop a moving object. A force can change the speed of a moving object. You imagine an object which is already in moving situation, moving condition. Now we are going to apply a force on the object. So it is going to change the speed of the object. It is going to change the externally applied force will change the speed of the object. Depending upon the direction, it will increase the speed or it will decrease the speed of the moving object. A force can change the direction of a moving object. As discussed in the previous point, the force which is applied on the moving object can change its direction. The fifth point is a force can change the shape and size of an object. The externally applied force can change the shape and size of the object. So this is an important property required for all the material so that we can do some machining operation on the materials. So by means of applying the external agency, we can change the shape of the object, we can change the size of the object. So these are all the effects of forces. Then what is a system of forces? A group of forces or a set of forces acting together on a body form a system of forces. இந்த படத்தில் பார்த்தீங்கன்னா ஒரு ஹூக் கொடுத்துருக்கோம். இந்த ஹூக் இஸ் கனெக்டட் வித் சம் டை ராட் சங்கிலி மூலமாக நம்ம கனெக்ட் பண்ணியிருக்கோம். ஸோ இப்போ இதில் ஃபோர்ஸஸ் நம்ம அப்ளை பண்ணும் பொழுது அந்த குரூப் ஆஃப் ஃபோர்ஸஸ்க்கு பேர் என்ன சொல்கிறோம் அப்படின்னா சிஸ்டம் ஆஃப் ஃபோர்ஸஸ் அப்படின்னு சொல்கிறோம். இந்த டை ராடில் பார்த்தீங்கன்னா ஹூக்லேருந்து யூ கேன் சி F1 is acting in this direction and F2 is acting in this direction. Okay, there are two forces F1 and F2. Finally we are getting the resultant force also. So there are three forces acting on a single object. Okay, this system is called as system of forces. What are the types of forces? Forces can be broadly classified as coplanar forces and non-coplanar forces. Coplanar forces can be further divided into concurrent forces, non-concurrent forces, collinear forces. These collinear forces can be further classified into like collinear, unlike collinear. Similarly, the parallel coplanar forces can be further classified into like parallel and unlike parallel and non-parallel. The non-coplanar forces can be sub-classified into concurrent forces, non-concurrent forces, parallel forces and non-parallel forces. We can see the nature of each force one by one in the following slides. First one is coplanar forces. What is a coplanar force? Line of action of all the forces lie on a single plane. Okay. You imagine there are two forces F1 and F2 are acting on an object. Both F1 and F2 are acting on a single plane. Here you can see both F1 and F2 are acting on the xy plane. These type of forces are called as coplanar forces. Then what do you mean by non-coplanar forces? Here the line of action of all forces are not lying on a single plane. The same two forces F1 and F2 are acting on a single object. You imagine forces F1 and F2 are acting on a single object, but they are not acting on a single plane. They are lying on different planes. For example, if you take F2 lies on x and z plane. F2 lies on x and z plane and F1 lies on xy plane. F1 lies on xy plane. Okay, both the forces are acting on a single object, but the forces are lying on different planes. This kind of system is called as non-coplanar forces. Then comes concurrent forces. What do you mean by concurrent force? The line of action of all the forces passes through a single point. You imagine we are having a cube. There are three forces acting on a cube at the node A. Okay, here you can see at node A there are three forces acting, force F1, F2 and F3. There are three forces acting on the node A of an object. Okay, all the three forces are acting at a single point. These type of forces are called as concurrent forces. Then comes non-concurrent forces. What do you mean by non-concurrent forces? Line of action of all forces do not pass through a single point. Okay. In the previous case, all the three forces acted at a single point. But here there are three forces acting on the object, but they are not acting at a single point. This kind of forces are called as non-concurrent forces. Then collinear forces. It is an important type of forces, collinear forces. What do you mean by collinear forces? Line of action of all the forces are passing through a single line or are acting on a single line. We look at this figure. There are three forces, F1, F2 and F3. All the three forces have their line of action as a single line. For F1, F2 and F3, the line of action is going to be a single line. These type of forces are called as collinear forces. The collinear forces can be divided into like collinear and unlike collinear forces. What is the difference? In the like collinear forces, the line of action of all forces through a single line and they are acting in the same direction. You look at this one. Okay, line of action of all the forces are acting through a single line and all are acting on the same direction, F1, F2 and F3. Here all are acting in the same direction, all are acting in the same direction. Unlike collinear forces, what is the difference between unlike collinear forces and collinear forces? In the unlike collinear forces, the line of action of all the forces are acting on the single line but in different directions. You can see F1 and F3, they are acting on the same direction and the F2 is acting in the opposite direction. But all the three forces has the line of action as a single line. This kind of forces are called as unlike collinear forces. Then parallel forces. What do you mean by parallel forces? Parallel forces are nothing but forces which are having line of actions parallel to each other. Here we have three forces, F1, F2 and F3. All the three forces have their line of actions parallel to each other. So they are called as parallel forces. They are further classified into like parallel and unlike parallel. How to classify them? Depending upon the direction. Okay. In the first case, F1 and F2, the line of action of the two forces are parallel to each other and they are acting in the same direction, and the two forces are acting in the same direction. So they are called as like parallel forces. And in the second case, we have two forces, F1 and F2. Two forces have line of action parallel to each other, but both are acting in the opposite directions. So they are called as unlike parallel forces. They are called as unlike parallel forces. Non-parallel forces. Here the line of action of all forces are not parallel to each other. Okay. Here the line of action of all the forces are not parallel to each other. Okay. F1 is acting in the horizontal direction, F2 is acting in the vertical direction. Their line of actions are not parallel to each other. Non-coplanar concurrent forces. What do you mean by non-coplanar concurrent forces? Line of action of all forces are not lying on a single plane but passing through a single point. Look at this figure. We are having an object. In the object we have a node A. In the object we have a node A. There are three forces, F1, F2, F3. They are not acting on a single plane but they are acting at the single point. So these kind of forces are called as non-coplanar concurrent forces. Non-coplanar non-concurrent forces. What do you mean by non-coplanar non-concurrent forces? Okay. Line of action of all the forces are not lying on a single plane, okay, and at the same time they are not passing through a single point. In the previous case, we have three forces. All the three forces are acting at a single point A, single node A. But the forces F1, F2, F3, they are not acting on a single plane. Okay. But in this case, there are three forces, F1, F2 and F3. They are lying on different planes and they are not acting on a single plane, single point. They are not acting on a single point. This system of force is called as non-coplanar, non-concurrent forces. Non-coplanar parallel forces. What do you mean by non-coplanar parallel forces? Here the line of action of all forces are not lying on a single plane but parallel to each other. You see there are three forces. Once again F1, F2 and F3. They are not lying on a single plane but they are parallel to each other. If you take F1 lies on X and Z. F1 lies on X and F1 lies on X and Z plane. F1 lies on X and Z. F2 lies on Y and Z. F3 lies on X, Y plane. Okay, they are parallel to each other but they are not lying on a same plane. These kind of forces are called as non-coplanar parallel forces. Then comes the important one, resultant of forces. We have discussed that there are a lot of forces acting on a object like P, Q. They are acting on a particle simultaneously. Okay, then a single force which will produce the same effect as that of all the given forces is called as the resultant force. So what is the resultant force? If a number of forces P, Q, etc. are acting simultaneously on a particle, then a single force which will produce the same effect as that of all the given forces is known as resultant force. You imagine a point A. There are some forces F1, F2, F3, F4. They are acting on the point A. Okay. There will be only one force R which is called as the resultant force. It gives the same effect as that of all the forces. Here the forces F1, F2, F3, F4 or we can say P, Q, R, S are called as component forces. They are called as component forces. Then how to find out the resultant force R? The resultant force of the component forces are the point through which it acts may be found out either mathematically or graphically. The resultant of a force system is a single force which produces the same effect as that of the force system. It is an equivalent force of all the given forces. Here we have two forces P and Q. They are acting at an angle theta between each other, okay, at a point A. The two can be resolved into a single force called as resultant force R. They can be represented by a single resultant force R. What is the principle of transmissibility? Principle of transmissibility states that the conditions of equilibrium or conditions of motion of a rigid body will remain unchanged if a force acting at a given point of the rigid body is replaced by a force of the same magnitude and the same direction but acting at a different point, provided that the two forces have the same line of action. So the principle of transmissibility என்ன சொல்லுது அப்படின்னா, ஒரு மூவிங் பாடியோட கண்டிஷன்ஸ் டிஸ்டர்ப் ஆகாது. எப்போ டிஸ்டர்ப் ஆகாது? அது மேலே ஆக்ட் பண்ணுற ஃபோர்ஸை இன்னொரு ஃபோர்ஸ் ஹேவிங் சேம் மேக்னிடியூட் அண்டு acting in the same direction, but now we are going to replace the point of action. Okay, you imagine we are having an object like this. Okay, this is going to be the line of action. This is the line of action. Force F1 is acting here. The object will not be disturbed by introducing another force F2, which is having the same magnitude as F1 and acting in the same direction to F1, okay, but the point may be different. Here we are going to apply the F2, force F2. We are going to use the same system, but now the force F1 is replaced by F2, but the body will remain in the same equilibrium, same conditions of equilibrium. This principle is called as principle of transmissibility. This picture will give you a clear idea. Okay, we are having an object, a force F is acting at your location. Okay, a force F is acting at your location. Okay, you say A. Now this can be replaced by another force F dash which is acting at your point B, so that the conditions of equilibrium of the object is not disturbed. This principle is called as principle of transmissibility. So how to find out the resultant force? What are the methods adopted to find the resultant force? In the analytical method, we are having trigonometric method and resolution method, and in the graphical method we are having triangular law of forces and polygon law of forces. We will discuss them one by one. First one is the analytical method. Here we are going to use the trigonometric method to find out the value of the resultant force. This analytical method can be used when we have only two concurrent forces. There are only two concurrent forces P and Q acting at a point O. Okay. The angle between P and Q is going to be theta. Now we can find out the resultant force R for the system, okay, by using the trigonometric methods. Okay. You imagine R is going to be the resultant force. R is going to be the resultant force of the system. Okay. And it is acting at a point. You imagine we can define a new point as A. According to the parallelogram law of forces, now we are going to drop a line CD from C perpendicular to the line AD. Okay. So we are going to draw a line from C which cuts the line AO at a point D. Okay. So we are going to drop a line from C which cuts the horizontal line AO at a point D. Okay. So the CD is perpendicular to AO. The resultant force is given by R. The resultant force is given by R. Applying the trigonometric methods, how to find out R? R is equal to AC. How to find out AC? AC is the square root of AD square plus CD square. AD square plus CD square. You just imagine this triangle A, R, C, D. R is going to be the resultant force AC. So AC is equal to square root of AD square by CD square. Okay, AD square by CD square. The resultant force R is equal to AC and it is given by square root of AD square plus CD square. Okay, AD square plus CD square. What is AD? AD can be divided into AO plus OD. Okay, the sum of AO plus OD will give AD. So here we are having AO plus OD, square root of AO plus OD square plus CD square. Let this is be equation 1. Now we have AO as P and OC as Q. In the triangle OCD, now we consider triangle OCD. What is sin theta? Sin theta is equal to opposite side by hypotenuse. Opposite side by hypotenuse. So for this one, for this angle theta, CD by sin theta is equal to CD by Q. CD by Q. Okay. CD by Q. Now CD is equal to Q sin theta. CD is equal to Q sin theta. Similarly, cos theta. What is cos theta in this triangle? Cos theta is equal to adjacent side by hypotenuse. What is hypotenuse? Q. So OD by Q. Therefore OD is equal to Q cos theta. OD is equal to Q cos theta. Now substitute these values in equation 1. It gives square root of P plus Q cos theta square plus Q sin theta square. This is equal to A plus B the whole square. What is A plus B the whole square? A square plus 2AB plus B square. So P square plus 2PQ cos theta plus Q square cos square theta. Okay, this is going to be this one. What is Q sin theta square? Q square sin square theta. Now we can sum these things. P square plus 2PQ cos theta plus between the two terms we can take Q square outside. We can take Q square outside. Q square into cos square theta plus sin square theta. What is cos square theta plus sin square theta? This is equal to 1. We know that sin square theta plus cos square theta is equal to 1. This is going to be square root of p square plus q square plus 2pq cos theta. So how to find out the magnitude of the resultant force R? It is given by R is equal to square root of p square plus q square plus 2pq cos theta. How to find out the angle between the resultant force? How to find out the angle between the resultant force? So this is going to be the angle between the resultant force and the force P, horizontal. Okay. If you consider this triangle once again, ACD, the angle is going to be alpha. Okay, the angle is going to be alpha. The angle is going to be alpha. So how to find out this alpha? We know that tan alpha is equal to opposite side by adjacent side. Opposite side by adjacent side. What is opposite side? CD. What is opposite side? Opposite side is given by CD. Opposite side by CD. What is opposite side? Opposite side is given by CD. Adjacent side is given by AD. Opposite side by adjacent side. So tan alpha is equal to opposite side CD divided by adjacent side AD. So tan alpha is equal to q sin theta divided by p plus q cos theta. Okay, from this we can find out the value alpha. What is alpha? Alpha is the angle of resultant force from the horizontal. Angle of resultant force from the horizontal. From these equations we can come to a conclusion that when theta is equal to 0, then R is equal to P plus Q. R is equal to P plus Q. Okay, when theta is equal to 0, R is equal to P plus Q. What is this? It means P and Q are parallel to each other. When theta is equal to 0, then R is equal to P plus Q. It means that P and Q are parallel to each other and are acting in the same direction. When theta is equal to 90 degree, then R is equal to square root of P square plus Q square. It means that both are acting mutually perpendicular to each other. Then theta is equal to 180 degree, then R is equal to P minus Q. It means that the force P and Q are acting in opposite directions. They are acting in the opposite directions. This method is called as a trigonometric method of finding the resultant force. The next one is the analytical method by means of resolution or method of projection. This method is very useful to determine the resultant of number of forces acting on a body. Okay. In this method, by determining the horizontal components and the vertical components of all the forces and by adding the forces, the resultant force is calculated. Look at the diagram. Look at the figure. In this figure, there are 4 forces P, Q, S, T are acting on an object. Okay. They are acting in different planes. Okay. They are having different angles. They are acting at different angles on the component. How to find out the resultant force? Okay. This is the figure. So for the force P, you can take for the force P, the angle with the horizontal is theta 1. So the x component is going to be P cos theta 1 and the y component is going to be P sin theta 1. Similarly, for the component for the force Q, angle with the horizontal theta 2, the force Q is having an angle theta 2 with the horizontal. So what is the x component? X component is going to be Q cos theta and the y component is going to be Q sin theta 2. For the force S, okay, for the force S which makes an angle theta 3 with the horizontal, the x component is going to be S cos theta 3 and the y component is going to be S sin theta 3. Similarly, for the force T, okay, which has an angle theta 4 with the horizontal, x component is going to be T cos theta 4 and the y component is going to be T sin theta 4. So how to find out the magnitude of the resultant force? The magnitude of the resultant force is given by R is equal to square root of sum of all horizontal forces square plus sum of all vertical forces square. Okay, what is sigma x? Sigma x is nothing but sum of all horizontal component of the forces acting on the body. Sigma y is nothing but sum of all vertical components of the forces acting on the body. Similarly, the angle, resultant angle alpha can be determined by tan inverse of sigma x slash sigma y. Then comes the triangular law of forces. Okay, it states that if two forces acting simultaneously on a particle be represented in magnitude and direction by the two sides of a triangle taken in order, the resultant may be represented in magnitude and direction by the third side of the triangle taken in the opposite order. Okay, which we have discussed already. Using the trigonometry method, we solved this problem. Next comes the polygon law of forces. It states that if a number of forces acting simultaneously on a particle can be represented in magnitude and direction by the sides of a polygon taken in order, the resultant may be represented in magnitude and direction by the closing side of the polygon taken in opposite order. So far we discussed about what is a force, what is the definition for force, what are the types of forces, and what are the components of resultant force, how to determine the resultant force using trigonometric method and analytical method. So with this we are coming to the end of this session, and we will meet in the next session. Thank you.